Hello everybody, welcome to day 5 of Advent of Code 2023. Today I'm recording this video from Montreal where I just landed to 1 hour ago, so I will be soon jet lagged, but I will try to solve the day 5 puzzles before that happens. Sorry for the audio quality, it's gonna be worse than usual, but at least I do the video, so that should be better than nothing. So let's start with day 5. So today we will be dealing with fertilizers. So there's a usual backstory, and we need to fertilize the ground. So we are getting an almanac as an input, which lists all the seeds that we need to get planted. It lists also the type of soil to use with each kind of seed, then the type of fertilizer to use with each kind of soil, and the type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, and numbers are used within each category. So it can be that soil 1, 2, 3 is not the same thing as fertilizer 1, 2, 3. Okay, so this is an example input. A lot of numbers in this one. So essentially we have initial line, some seeds, and then some groups separated by space apparently. Okay, so in each, so we have the initial seeds there, and then we map numbers from a source category into numbers in a destination category. So if we convert the seed number, the source, to soil number, the destination. And every source number every map describes entire ranges of numbers that can be converted. So each line within the map contains 3 numbers: destination range start, source range start, and range length. So that means what? So destination range start is 50, source range start is 98, and range length is 2. So it means that this is like 2 values, 98 and 99, and destination is 50 and 51. So seed number 98 corresponds to 50 and 99 corresponds to 51. It makes quite a good sense, I think. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to seed soil number 10. So 10 wouldn't be in any of these ranges, so it would map to the same number. Makes sense. And so we generate the soil number required for each initial seed number. So we essentially like map everything to the location. Okay, so just example, we need to find the lowest location number that corresponds to any of these initial seeds. So we map everything in this sequence, and then we get finally the location, and the lowest number is gonna be the one that we are looking for. Pretty wordy puzzle, but let's hope it's not gonna be as complicated as it looks by the description. So essentially it seems that we will be just going through the individual categories and mapping our current number to a mapped version of it. Kind of a transformation of numbers. And I will paste the simple input here, and I will start writing the code for this. So I will create a file input stream and open the file for read, and then I will do so. Well, actually I will do a string reader as well. String reader. So I will now be able to read line by line. So what I will do is first read the seed numbers. So those will be the seeds. And I will read the line. This is going to be the initial line. I will substring from it this initial text, so I get just the numbers. Start index gonna be just not sure here though, so I'll do this right here, and now we will split it by space, remove empty entries, and trim, and parse the numbers to a list. And we can actually just assign this seeds to the list there, or even to array. You will not modify it anymore. So we get the seeds, and now we will go through individual categories. So while we have a line here, so we technically get, well, we get a line. We essentially go through, there is an empty line, then the header, and then the individual numbers. So we will go through, rather, how do we, well, let's create actually use some useful classes for this. So I will map range, or how do we call it? So I'll create a seed range. It should be a class that will be initialized by, so we will have a seed range. We will have source start or destination start, right? Start. I'll just close this. This is annoying. Something else maybe, or even just this. Make it smaller so it's more visible. So make this bigger. So hopefully now it's more visible. So we'll on each line there's destination, range start, source range start, source start, and length, range length. So this will represent a range that's there in the input, and I will create some helpful fields for these values. And what I can do now is, for a given number, for a given value, I can check if it is in the range, is in source range. So we check if the given number is in the range that the seed range covers. So if the value is greater than source start and value is less than equal to, and now its range length is the So it's less than destination start plus range length. That's correct. So not destination, but resource. So we check if the value is valid for this specific range. And if it is, then we can also provide a map function, map source into value, and we map it. We map the, yeah, that's exactly what Copilot generated. We map from like the difference between the value and source start. Just to make it more readable, we'll do destination start plus value minus source start. So this will map the value to the transformed version based on the destination. And then we also will have some kind of class that will contain multiple ranges. Seed range group that will contain a list of seed ranges. So we will initialize this field. And now we will map the value by checking, yes, for each range in seed ranges, if value or seed, if range is what is the method name here, is in source range. And what is it complaining here? Oh, right, seed range, not seed group. That's right. So if the range contains the value, then we return map source. But if none of the ranges match the value, then we will just return value, because that was the fallback that they mentioned. If no range contains that value, we just return the same value back. And this should take care of the main part of the logic. Now just we need to correctly parse the input. So basically what we need to do, there should be how many of these? So 1, 2, 3, 4, 5, 6, 7. So 4, 2, 7. It's going to be 7 groups. And I will just make this nicer by making this a constant. And it's going to be 7. So we always do the following. I will just read line here. So reader line. We skip the empty line exactly. And now we do reader read line. Oh, actually we can put it here. That's fine. So we this is the empty line. This is the header, and now the individual groups. Or can we do this like? Oh, we cannot do this way. We don't know how many lines there will be, so I will do it like this. So reader read line. I will read the empty line. Then we need header for each group, and then while we so for while we have the string line goes read line is not equal to or rather string is null empty line. So we wait until we reach an empty line or we reach null line, which is the end of the file. And if we reach the empty line, we go back to the beginning, read the header, and read the next group. So we create a seed ranges, list of seed ranges that we read, and for each line we do parts line split by space, and then we select in parts to array, so we get the individual parts of that line. So the seed ranges we add exactly, so the source, this is the destination start, source start, and length. And then when we have all of them, then we create the seed range group from that whole thing. And what we now do is that we can for each seed we can map the current value that we have to the updated version based on this current seed range group. So this is a kind of a object-oriented solution, I would say, but it should hopefully be enough now. So if I now write line seeds min, this should give us the final minimum value of the seed that mapped to the lowest value here. But we'll see. Maybe I made some bug there, so it might not work initially. So what happens? Not sure if it's executing or somehow frozen. That is odd. Am I stuck somewhere? Oh, right. I forgot one important thing that I need to do read line, which I didn't do here. So try again. Was the infinite loop there. So now we should get somewhere else. So it's 35 and result, that's promising. So that's 35. So let's try on the big input. These are quite huge numbers, but hopefully they fit into integer. Let's try to run this here. Okay, so integers are not enough here. So let's switch everything from int to long. And let's see what happens then. Oh, quite a big number. Let's see what the verifier says. All right, that was a good, that was lucky. The first answer is correct, so we are able to proceed to part 2. Right, so I took a small break because I was very tired, but now I'm ready to take on the second part of the problem. So let's look at the part 2 of today's puzzle. So now for the second part, instead of seeds line containing individual seed numbers, we'll have a range of seeds. So essentially, instead of 79, 14, 55, 13, we have now 79, 80, and so on until 92. So 14 values there, then 55 and 13 values afterwards. So that's so it's essentially the seeds line is divided into pairs of numbers, which give us the actual ranges. And this is certainly much more complicated problem, because now for the sample input, the one that's here, it's not a big deal because we can just go through 14 and 13, so 27 different values and go through the whole thing. But the puzzle input that's there is considerably larger. So this is like 2 million entries and 5 or even 52 million and so on. So very huge ranges, which probably would be possible to process. I'm pretty sure with today's CPUs, it is possible, but it would take a long time. So I'm not sure if we can make this better. So let's first edit the current state of the program to handle the new input. So what I will do, I will create a new list of map groups, where I will be storing those groups that I create here. And this will give us all the groups. And now the seeds are no longer actual seeds. So seed pairs. And we need to turn them into actual seeds. So maybe let's create a, well, seed ranges now has multiple meanings. So I would rename this to range map. Like it's a mapping a range to some destination. And this would be then a range map group. And then we can have class seed range, which will be essentially a range start and length. So it will be a range of values with like public long end would be this is premise length, and also let's make it a record because it's not going to be changed in any way. So end is going to be start plus length minus 1. So there's a yes. So this is going to be a range of values, and we will read this from the input. So for seed pair t in seed pairs length. So I will divide by 2 because there are pairs. So we so 2 values equal 1 pair. So I will do starting seed is gonna be the first value in the pair, and length is gonna be the +1 value of the pair. So now we can create a seeds list, seed range. It's gonna be our seeds, and we add new starting seed and length. So this will create a list of seeds, and now we can process them as before. So for each map group in map groups, we can go through each of the seeds, or rather not this way. We need to, so we will be gathering kind of best value along best. It's gonna be initially along max value, but it's gonna be the minimum value that we can reach. So we will be yes, so for all of those we will be thinking how to write this in a most simple way. So for let's do this maybe. So for each seed range in seeds, for each seed range, I will go through its seeds. So seed, level I, so seed range length, where seed will be the seed range start plus I, and now we will be processing it through the normal approach, so map group, and we will be mapping that seed continuously, and then we can check if best equals math min best or the current seed value, and then if we output here, we should get the best value of all the seeds that are on the input. Hopefully, if I'm not mistaken here. So let's see if that's the case. So it's for the 6, and that's correct. So that's the minimum value, but now that's for the simple input. But for the long one, the big one, it would take a long time. So we can actually run it against the big file. We can do it, but I would run it separately. Like I will build this and just run that on the background, and we will try to figure out a better solution for this. So I will go here. In the meantime, let this run. So 5xz run it. So it will be running on the background, but we will try to figure out some better solution which will be more efficient. And that solution could be that we would be mapping not individual seeds, but the whole ranges in themselves. So what I think we should do is that we would like instead of value, we would map seed range, a whole seed range, and mapping a seed range against a group of range maps could produce multiple different seed ranges, because if a seed range is from 0 to 1000, that we have multiple different smaller ranges that map to some smaller ranges, we can a part of that source range could fall into one map, another to another map, and it could break down into multiple smaller ranges. So this would be mapping a range to multiple smaller ranges potentially. So results, I will create a list of results, and now what I need is for the ranges to be ordered by start, and we don't have those public, so I will turn this into, can I turn this in, or turn this into destinations? I'll just turn this into properties. So no, it's not int but long. So long source start and long range length. Maybe we don't need this anymore, so I can maybe turn this whole thing into a record long destination start, long source start and length. All right, so maybe this method will not be necessary anymore, but let's keep them for now. So we can take source start. So we will order the maps within the group by their starting point, so that we know that when we map, we are going from the smallest ranges onwards. And now we will go from map ID, well, maybe for map in source seed ranges. We'll rename this maps because it's no longer seed ranges, it's maps. So now for each of the maps, we have two options, or actually three options. One option is, well, I will also store this like a remaining range. So we slowly cutting off parts of the range or the input range and creating smaller ranges. So first option is the whole remaining range is before the map starts. In that case, we cut map identity map, because it means that this group has no mapping for it, and we stop processing. So if, or maybe like this, part or all remaining. So for this part, and if if there is a part that is not intersecting with the current map but is before it, then we cut it off, add it to results, and then we check for intersection with current map. If there is, we cut and map and update remaining range. So this is kind of the pseudocode of what we are going to do. It's not perfectly described, I think, but we will hopefully figure it out as we go. So we first need to check if remaining turned off Teams so they don't ping me. All right, so remaining range start is less than map source start. So if the remaining range starts before the current map, we cut off that part. So our cut off is new seed range. It starts with remaining range start and ends with the end will be length cut off length is gonna be either length of the remainder itself or the difference between map source start minus remaining range start. So is that correct? So if yes, so we want to cut off only the part that does not overlap with the current map. So that should be hopefully correct. Cut off length. So we cut this part off. And update the remaining range. So the remaining range will now be yes, so I think that's actually exactly what we need. So we started after the cutoff length, and then we decrease the length by the length that we cut off. So that should be fine. And now if remaining range length is less than or equal to 0, then we're done. Break. Yes. And if not, then we check for intersection. So if remaining range start is greater or equal to map source start and remaining range start is less than source start range length, so it really starts somewhere within the current map, we do another cutoff. So we take well, this is not going to be correct probably, but let's see. Thinking in ranges is kind of confusing. So it's either the remaining length of the range or source start plus minus remaining range start. It's so confusing. Oh god. Okay. What we want is the intersection, kind of. So var section intersection length. So it's the minimum of the remaining range length and source start, the start of the source mapping, plus range length minus remaining range start. Yeah, right, because it it should be either the if it's inside the map itself completely, then it's the range length, and if it's overflowing that map, we just take the start minus the length. So that should be making sense. And we section will be a new range which begins at remaining range start and is intersection length. So this is the intersection that is fully covered by this map. So we can now do map transform intersection, which is gonna be a new transformed range, and that one we will be adding to results at transformed range. And now remaining range will be again updated by the intersection length. So that should be hopefully all we need. Hopefully. So if again, if we the remaining range length is 0, then we end. And finally, if remaining range length is more than 0, then we add that itself to the results. All right, and now this I go and make 2 array. Very confusing code. Well, I'm not completely sure if it's gonna work in the first attempt, but we'll see. So we need to transform this. So we'll do new seed range. Map source intersection start intersection length. So we map the start and the rest will be the same. The length remains the same. All right, so let's make this a struct so we avoid allocating too much things. And if I'm not wrong, as I could be, this should be enough for us to solve the problem now. So yeah, what I can do now is do for each group in groups. Seed ranges. And what I can take is the seeds. And I can do group map seed ranges to array. To array like this. So I can take the seed ranges. Okay, I see. So our new seed ranges. For each seed ranges, we map it and add to a new list. Or maybe like let's do it like this. Seed range. Seeds. So well, we start with these seeds, and then we take new seed ranges. It's gonna be a new list of seed range. That's gonna be this will contain the updated versions. So at the end of this, we will just set seed ranges equals new seed ranges, and that should be it. Hopefully. So at the end of this whole endeavor, I will do seed ranges minimum select start and take the minimum start, and that could be it. So what I will first do is to verify this on the sample file, because I could have made many plus or minus 1 mistakes. So this needs to be verified. This was still running, so I don't really need to care about this anymore. But let's run this. And this is complaining because of this, because I reinitialized something. Okay, so maps. All right, so this should be okay. 46, that's promising because it did return the correct value at the first attempt. So now let's try with the big file, but I'm afraid there must be some bug. Okay, we have this huge value. So fingers crossed. All right, it's correct. Okay, so that's a very big relief because this was very surprisingly complicated to figure out the ranges and manipulation between ranges and mappings and so on. So it was kind of very confusing problem, especially after the long flight. But I'm pretty happy that this worked out. And we have now both problems of day 5 solved. So I thank you for joining me. I will do another quick video with ChatGPT versus this problem. I'm afraid this time it's gonna be complicated for ChatGPT to solve, but we'll see. Maybe we'll be wrong, and the AI will figure out a proper solution which is efficient and will give out the right result. We'll see. So thank you for joining. If you want to be notified about new videos, subscribe, and I will see you in the next video. Have a great day and keep coding.